Hi, so today we're going to learn about exponential, and then this is under college algebra review. So the first problem says we have 10 to the x equals 1000. So this is a typical exponential form, like 5 to the x, e to the x. So our goal is to solve for x, right? We got to figure out what x is. So the key in exponential and logarithmic is to try to get the same base. So we have a 10 and then 1000. What do you think our same base could be? I think our base could be 10, right? So what's another way of saying 1000 in the base of 10? Couldn't we say 10 to the 3? 10 to the 3 is the same thing as 1000? Yes, we can. So let's rewrite the right side. So 10 to the 3 is the same thing as 1000, and then the left just stays the same because it has a base of 10. So when you have the same base, you just could, that's a good thing, and then you just pretend the base isn't there, so you just bring down whatever is left. So we get x equals 3, right? So this is one of our possible x equals 3. So let's check it. So we put 3 in back to the original equation. So does 10 to the 3 equal 1000? Yes, it does. So that's true, and then our x must be true, x equals 3. Okay, let's do the next one. Number 2 is 10 to the 3x plus 5 equals 100. So we need to have a common base, so we'll say our common base is 10. So this is okay because it has a base of 10. Now let's just change 100. 100. What's another way of saying 100 in base of 10? 10 to the square, right? Because 10 to the square is the same thing as 100. So that's true. So, and then we just bring down the left. So you have the same base, so you just ignore it for now, and then you bring down whatever is left. So you have 3x plus 5 equals 2. So let's solve for x. So let's subtract 5. So we have 3x equals 2 minus 5 is negative 3. Divide 3 by both sides. X equals negative 3 over 3 is just negative 1. Now let's check it. So you put negative 1 back into the original equation. So 3 times negative 1 is negative 3 plus 5 is positive 2. Here, so it's like 10 to the negative 3 plus 5. Is this true? So that equals 100. Does 10 to the second power give you 100? Yes. So it's true. So we can say x equals negative 1. So yeah, the main goal is to get the same base and then try to solve for x. Number 3, we have 2x plus 1 equals 1/8. So we need a common base, 1/8. This one is a little tricky because we have a fraction, but let's look at the 8. What's another way of saying, what's another way we can write 8 as? Let's try base of 2. So what's another way of saying 8 in base of 2? We could say 2 to the 3 is the same thing as 8, right? Yes, but we have a 1/8, but we need that 8 to be in the denominator. So couldn't we say 2 to the negative 3? 2 to the negative 3 is like the same way as 1 over 2 to the positive 3. That's how you do negatives, right? So 1 over 2 over 3 is the same thing as 1 over 8, because 2 to the 3 is 8. So we just figure out what our base is going to be on the right side. So the left is 2 to the, it doesn't change, 2 to the x plus 1, and then the right is 2 to the negative 3, because 2 to the negative 3 equals 1/8. So the bases are the same, just ignore it for now. So x plus 1 equals negative 3. Let's solve for x, so we can subtract 1. So x equals negative 4. Now we got to check it, so 2 to the negative 4 plus 1, does that equal 1/8? Let's find out. So 2 to the negative 4 plus 1 is negative 3, so 2 to the negative 3 equals 1/8. That is so true, right? Because we said that 2 to the negative 3 is 1/8, so true. So x must equal negative 4. Number 4. We have 3 x squared times 9 to the x equals 1/3. So this looks confusing at first, but it's really not. So we have a 3, 9, and 1/3. Let's have a common base of 3. Let's get everything in base of 3. So what's another way of writing 9 in a base of 3? 3 square, but you have to remember there's an x, so it'd be 2 times x. And then bring down, don't forget this whole thing, so it's 3x squared equals, okay, what's another way we can say 1/3 in a base of 3? 3 to the negative 1 is the same thing as 1 over 3. So it'd be 3 to the negative 1. Good, everything has a base of 3. 3, 3, 3s. That's all we want. So, okay, so remember the rule for multiplying exponent, like powers? Like, let's say you have a 5x times 5 squared. That's really saying 5, when we're multiplying exponents, you're really adding, so that's like x plus 2. So what would this be here? So we would have a 3 to the x squared plus 2x, right? Because when we're multiplying these, you're really adding. So same base, ignore it for right now, so it's x squared plus 2x equals negative 1. We got to solve for x, so we have to have the right sides all 0. So I'm going to get rid of this negative 1 by adding 1 both sides. So this is going to be x squared plus 2x plus 1 equals 0. And then we'll do our simple factoring. So this is x and x. What two numbers multiply gives you positive 1, and when added gives you positive 2. Plus 1 and plus 1, right? 1 times 1 is 1, 1 plus 1 is 2. So we get two answers. X equals negative 1. Okay, so and -1. So we're gonna put, so we gotta check it. So first we gotta put the -1 back into the original equation. So wherever there's an x, you plug in -1. So it'd be 3. What is -1 squared? +1, right? Times 9 to the -1 equals 1/3. So 9 to the -1 is really saying 1/9, and then times it by 3. So 3 times 1 is 3/9, but when you reduce 3/3, that becomes 1/3 because we're dividing everything by 3. Right? So what I did was 3/9 is reduced by 1/3. So that's true. So our two answers is x equals -1 and x equals -1. Okay. Let's do another one. Number 5. We have 2x squared times 2x equals 1/8. So we need a common base. I want our base to be common base of 2. So we have 2 here, so we don't need to touch that. So what about the 4? What's another way of saying 2 to the what gives you 4? 2 squared, right? 2, and then don't forget this 2x. Okay, and then what's another way of saying 2? To get 2 to the what gives you 1/8. What about 2? How do you get a common base of 8 in the base of 2? So 2 to the 3 equals 8. So 2 to the -3 equals 1/8. 2 to the -3. Okay, so let's simplify. So this would be 2x squared times 2 times 2x is 4x. Because remember, this is like, yeah, that'd be 4x equals 2 to the -3. Okay, so let's look on the left. We're multiplying exponents, so when you're multiplying exponents, you're really adding. So this is going to be 2x squared plus 4x equals 2 to the -3. So we have the same base, you just ignore it for now. And then let's get the right side 0, so we're going to add 3, both sides. So we get x squared plus 4x plus 3 equals 0. And then that's factors. So two numbers multiplied 3 and then added gives you 4. I'm going to do +1 and +3. So x equals, we're going to get two answers, -1 and x equals -3. Okay, so we got to check for both. So I will start with a -1. So 2 to the -1 square is +1 times 4. 4 to the 2 times -1 is -2 equals 1/8. Is this true? So 4 to the -2 is really saying 1/4 square, and then don't forget the 2. 2 times 1, 2 to the 1 is 2, so it's just 2. So 1/4 square is 1/16, and then times it by 2, don't forget the 2, so that's 2/16. Does this this reduces by 2, so it's 1. 16 over 2 is 8. So 1/8 equals 1/8. So that part's true. So -1 is true. Now let's do -3. So 2 to the -3 squared is 2 to the +9. And then 4 to the -3, which is -3 times 2 is -6. So 4 -6 equals 1/8. So 4 to the -6 is 1 over 4/6, and then times it by 2/9. 2 to the 9th is 5 1/12, and then 4 to the 6th is a really big number, 4096. I put it in a calculator and I'm going to get 5, so what 512 over 496 is it'd be decimal 0.125, and then 1/8 is the same thing as 1.25. So this is so true. So we can conclude that both of these answers are correct, or possible. And that was the last one, so that's it for this section.